Okay, so the first thing we're going to do here is I'm going to open up a terminal, and I'm going to go ahead and do emerge --sync and EIX update. Now what that's going to do is that's going to sync with the Gentoo repository and then update with EIX so they have the updated repository list too. So I'll let that complete there. It'll be a few seconds. Okay, it pretty much told me I did not need to update right now. So let's go ahead and do an EIX Gentoo sources. Okay, right here. So I already emerged the latest one, but I'm going to go ahead and do it again for the tutorial. So I'm going to go ahead and type emerge equals Gentoo-sources and then a dash and then 5.11.10 and then auto unmask equals yes and then auto unmask equals right. And we'll go ahead and let that finish now. So what we're doing is we're compiling the Gentoo sources right now for the latest kernel. Yeah, just ignore him. He gets a little rambunctious sometimes. No, don't. Whatever you do, don't shit. Okay, so we're done compiling it here. Now we're gonna go ahead and do eSelect kernel list, and this is going to list all the Linux kernels that I have installed and compiled, but this is going to select the one for use. So I'm going to type in eSelect kernel set 22, and now that would be Linux kernel 5.11.10. So now what I'm going to go ahead and do is after I selected the kernel, the very next thing we want to do is we compiled the sources, but now we want to compile the kernel itself with the actual kernel configuration options. So in order to do that, we're going to use make kernel config, and we're also going to use gen-kernel. The reason for that is gen-kernel has a really good default preset, and it gives you most of your drivers for wireless, video cards, etc., integrated straight into the kernel. So when it comes to the kernel, you can either, a lot of your drivers are built directly into the kernel, or using modprobe to load them within user space. So you get it. There's some benefits from having them directly loaded into the kernel. And there's also some benefits from not having them loaded in the kernel. For example, the smaller your kernel size, the easier it is on the memory, and also the kernel tends to be a little snappier because the kernel size is smaller. But in general, I like to use gen-kernel because, like I said, it gives you most of the drivers, but then there's a few things I would like to add and change about it. So in order to do that, we're going to use a little bit of both of them, and this is how you do it. So we're going to go ahead and I think the bird wants to get out of here. Hold on one. Okay, so we're going to go ahead and generate the kernel now. So first, let's go ahead and type in gen-kernel. Like I said, we're going to be doing part gen-kernel and part make menu config. So gen-kernel, all because we want to do the initram fs and the kernel, and then kernel config equals default, because we want the kernel default configuration options to be set with gen-kernel. That prevents us from doing a lot of work. And now we're going to go ahead and do --no-old config equals or just actually no equals, just like that. And then we're going to go ahead and type in menu config. So at first we want to load the kernel configuration options at default. We want to make sure we're not generating or using an old config. And then we're going to want to boot into the menu config options with the default configuration options loaded from gen kernel. And we're compiling both the initram fs and the kernel. Another thing, because I use btrfs, I'm going to type in --btrfs. Put that switch there, or extension, whatever you want to call it. And then push enter to start the compiling process. And let it go. Okay, so now, if you look at this here, we've loaded the make menu configuration options for the kernel, but it has all the default options now for gen kernel in it. Now we can go ahead extra stuff that gen kernel didn't have in here. So for me, because I'm going to be doing this mainly for this is going to be an all-use system, we're going to kind of configure this so it's a little bit better for performance. So let me show you all how to do that here. So I have a T7610 workstation. Now when I use gen kernel, it forgets one of the LSI drivers I need for my SAS controller. Otherwise, I won't be able to boot in my Linux installation. So I'm going to go ahead and get that. So I'm going to go ahead and go over to device drivers. I'm going to SCSI device support. And then I'm going to go down to low-level drivers. And then I'm going to go down here and enable all this LSI stuff directly in the kernel. Now M means it's a loadable kernel module, but we want this built into the kernel specifically. So I'm going to go ahead and change this to star, which M means it's a kernel module, star means it's built in. Okay, so I got all the LSI. Looks like I got all the LSI stuff here. Okay, now I'm going to back out of that menu. So now I got that LSI driver I need that's not there by default. Go back one, back another. Now another thing is I use BTRFS on my workstation with four 1.6 terabytes enterprise solid state drives. So well, I need to make sure I have my BTRFS built directly into the kernel as well. So I'm going to go over to File Systems, and you'll see where it says BTRFS File System Support here. I'm going to go ahead and make that built in. Okay, another thing I like to do is I like to make sure the process governor is set to performance. So it's usually using the highest frequencies possible, and it doesn't downclock as much during periods of idle or whenever you're calling specific workloads. It also helps the latency a little bit when you're doing KVMs. So I'm going to go over here to processor type and features. Now, because I have a Xeon, what I'm going to do is I'm going to go over to processor family as well. I'll make sure I have Xeon selected. Okay, so because of that, I want to set the performance governor. So I'm going to go over to power management and ACPI options, and I'm going to go down to CPU frequency scaling, default CPU governor, set scheduled. I'm going to go ahead and change it to performance, and I'm going to just turn off the other governors because I always want to be in performance. I don't want anything switching it to anything else by any type of Linux package or software. So I'm going to tell the kernel I don't want any other process governors built in besides the performance governor. So everything else is fine there for me. So I'm going to go back. One other option you're going to need for your kernel configuration is you're going to want to go ahead and make sure I think it's the I2C flag. You want to make sure it's disabled if you have a NVIDIA graphics card driver. Let me see if I remember that. Yeah, I2C right here. I2C support. If you don't, the kernel is going to complain when you're compiling it. So you're going to want to go ahead and go here to I2C, and then I2C hardware bus support, and then NVIDIA GPU I2C controller, and you're going to disable that. You don't have to. I've compiled my kernel with it. I just get the message complaining about it, but I've never seen an option with it, so I'm not exactly sure why it complains, but because it does, I'm showing you how to turn it off in this video. Okay, on the timer configuration. What you're going to want to do now is go to Processor Type and Features, scroll down to Timer Frequency, make sure it's set to 1000 Hertz, go back, then go to General Setup, go to your preemption model, and make sure it's set to preemptible kernel, low latency based desktop. Now what you're going to want to do is you're going to want to save your kernel configuration. So what I always do is I just type in kernel.config. Now what you're going to want to do is exit this menu and then exit the kernel configuration menu itself. It's going to ask if you want to save. It doesn't really matter because you just save, but you can do it again if you want. Okay, so now what you're going to want to do is you're going to want to go ahead and Control-C out of this. The reason for that is because if you let it continue compiling, it won't compile with your kernel configuration you just got done making in the kernel configuration menu. So Control-C out of it. Now what you're going to want to do is you're going to want to go ahead and just press up on your keyboard, and it should bring up your old command that you just issued for that. And where it says -- kernel config equals default, you're going to go ahead and delete default, and you're going to specify the kernel configuration file. So to do that, you're going to type /user source linux /kernel.config, and then you're going to go over and you're going to want to delete the menu config switch. Now what this is going to do is this is going to use the kernel configuration that you just created, and it's going to compile the kernel using that configuration. And then we're just going to go ahead and wait for the kernel to get finished compiling. Okay, real quick, while this is compiling, I'm going to go ahead and explain the reason for the importance of keeping TSC stable and why you set the timer resolution frequency higher and the preemption model. So, real quick, TSC is a clock source timer. It's based on timekeeping for your processor. Timekeeping can also have direct impacts on your IPC performance, which is your single-threaded performance across all cores. So pretty much, if you're not running TSC stable, you'll usually fall back into the HPET event timer. There's also a few more timers that you can fall back on, but generally, if TSC breaks, you go to HPET. There's a lot of debate on the internet, which is better, TSC versus HPET. If you have TSC running stable, you're probably looking at around a 10% increase across the board on clock-per-clock speeds. So it's very important to keep TSC stable. There's some patches you can do to BCD edit to help ensure that Windows is running the TSC clock source timer. When you're running the TSC clock source timer, you want to lock all of your cores at a single frequency and prevent any frequency stepping. Any type of frequency stepping is going to affect your latency and affect your processor's timekeeping ability. So you're going to want to make sure your C states are off and your processor is locked at a single speed. You can also issue commands to Intel pstate through the Linux kernel, so you can research your highest all-core turbo values and lock it like that. But if you have an unlocked multiplier, I'd recommend just locking all your cores to a single speed. And of course, disabling all your power management settings. Okay, so let's go ahead and do the default grub configuration for when you generate your grub bootloader menu. What this does is it just implements certain kernel boot parameters. So whenever grub's loading and starting up the kernel, it's letting the kernel know, hey, I want you to boot with these certain boot parameters. So that's the part we're going to do next. So I'm going to open up a terminal. I'm going to nano into etc default grub. Now here's all the kernel parameters, so I'll give you a quick breakdown of what they mean. ISO CPUs means these are the CPUs you want to isolate for a kernel-based virtualization machine. No hertz, makes it pretty much a tickless system on those cores. RCU, no RCU callbacks, it just prevents callbacks on those cores. Pretty important, especially with certain processors. With Ryzen's, they have a little bit of a crashing issue, at least at this date when I did the video. They're having a little bit of issues if you're not using this parameter. Now, these three settings right here are for kernel-based virtualization only. If you're not doing that, do not use these. Okay, now we're going to go on to here. Recommended performance enhancements for any system. Okay, now these are all the performance kernel command lines I recommend doing unless you're in a corporate environment or working or applying any of this on a server that is running multiple websites, has a lot of connections to it. Do not unpatch your security mitigations. If this is for personal, home, consumer end use, these things are going to be fine here because a lot of the security mitigations that you're disabling actually have a lot to do with your kernel-based virtualization, which means that if you're virtualizing a guest in the host, if you turn off some of these security mitigations, then certain information from the host is going to be exposed to the guest. Which can be an issue depending on the environment you're in. But for standard consumer use, these aren't really big of a deal, but they've deployed the patches throughout society anyway. But if you want to get the performance enhancements by disabling, go ahead and disable them. That's what I've done. Okay, so the first one I'm going to go over is USB core auto suspend. -1 pretty much just means disable. What that means right there is that is the power management for a USB. Every time there's a change in frequency stepping, you have a slight latency spike or a change in power management, or this also would give you extra interrupts you don't need. So you're going to want to make sure your power management stuff is off, including this. Idle equals pull. This helps prevent frequency changes by keeping the processor out of specific idle states. Max C states, this puts you at the lowest C state, which is the highest performance setting for power management when it comes to Intel CPUs. So this right here where it says processor max C states, you're going to want this to be 0, which is the lowest setting here, but it keeps your processor in the highest performance state and prevents processor frequency stepping. Watchdog here, some of these kernel parameters have actually been depreciated in certain kernel versions. Depending on the kernel version you're using, it may or may not work. Same with some of these watchdog ones in the force TSC stable and some of the security mitigations. Otherwise, all the other ones work. But I just apply them all. I just copy and paste these, which will be on the website. In the video, I always link below with the link to the actual guides on the website and how to do stuff. And then you just copy and paste all this there into your kernel parameters. The PCIe underscore ASPM equals off. That is to disable PCI bus power management. TCS reliable. It helps you maintain your TSC clock source. Clock equals TSC, same thing. Mitigations. This keeps a lot of the security mitigations off, which are the security patches for certain vulnerabilities. MDS equals off, disable security patch. It's same. Some of these your kernel's just going to ignore, and some of them it won't. But if you put all these in your kernel parameters, you should have most, if not all, the security patches that, in my opinion, if you're just consumer end, you're doing gaming or little video editing and stuff here and uploading to YouTube, I wouldn't even worry about it. Transparent huge pages. This allows your guest and host to share their huge pages. I put never because if you're doing kernel-based virtualization, you're going to want all those huge pages to be aimed at your KVM. This one right here is an important KVM-based virtualization setting. Now, and this one is same with this one. Now, you're going to see I have a few virtualization settings here, but now these can be on even if you're not virtualizing. They're not going to affect your boot or anything, and they'll just be there if you do it later. Now, these right here, if you shouldn't use any of these whatsoever if you're not doing a KVM on this system. So don't even worry about these. Net iframes equals 0. This uses the old device naming scheme for network devices like WLAN 0, F1, F2, instead of the newer device naming schemes, which they use ridiculously long names. I don't understand why they ever did that, and there's probably some good reason for it, though. I just don't know. But this is the way to use the old naming schemes. It helps, in my opinion. IRQ affinity, this is so you can afford your system interrupts to specific processor cores and prevent them from hitting certain cores. Do BTRFS. If you're doing BTRFS, which is an advanced RAID and disk management software, also allowing snapshots, you're going to need this unless you built the BTRFS kernel module in the kernel itself. Then you're not going to really need to do this. And in fact, if you did and you are using this, this is probably going to actually cause you more problems. I have it disabled specifically for the fact if I have it enabled, when I use grub mbk-config, it will compile a grub menu with this in there, and it just causes issues with from what I notice whenever I'm switching between snapshots. The snapshot actually won't fit, and I have to go into the grub menu itself and delete certain things for it to boot to my desired snapshot. But I'll get into that more later whenever I do a BTRFS based guide. And these are the kernel parameters I'm using right here. Also, here's for VFIO. Is it VFO or VIFO? I forgot. Hold on. VFI. Yeah, okay, I don't know why. Okay, I forget that sometimes. Okay, this is for VFIO. Right here, you can go ahead and you can have your kernel grab these devices for your KVM early in the boot process, right when your grub is calling up the kernel. This will grab those early in the boot process. Generally, I never use this because as long as you don't have certain system resources, using those devices, if you grab them with modprobe will be able to grab them just fine and detach them from the kernel and then be able to pass them through directly to your KVM. So I never recommend doing it like this, especially if you want to change stuff in the OS. And if you usually can't do it with modprobe, that just means you need further research on what's grabbing and using the device and keeping it from being detached from the kernel to the guest. But if you don't want to go that route and you just really want to do it earlier in the process, you can add the VFIO kernel perimeter, which you can just Google. It's not hard. It's like VFIO PCI-ID devices equals something along those lines. You can just Google it and pull it up real quick. So that's pretty much all you need. So if you're not using BTRFS or doing kernel-based virtualization, what I'd recommend is just copying all these right here and pasting them into there. Or you don't have to do it at all. You can do whatever kernel parameters you want. This is the ones I recommend for performance, though. So, okay. So, after you get done playing in your grub configuration file, whenever you're adding your grub kernel parameters, right here where it says grub command line Linux, that's where you're going to be putting the kernel parameters. If y'all didn't see that before. If you're watching this video and you're doing a Gentoo kernel, you probably already know how to do this by heart. Okay. So we're done with that. Now what we're going to want to do is we're going to want to generate the bootloader file with grub. So you're going to want to do grub-mkconfig-o/boot grub.cfg. And when I push enter, this is going to go ahead and generate the kernel and the initram fs in the grub bootloader menu. So now when you boot with grub, it's going to also execute those kernel parameters prior to actually booting the kernel. Okay, so before you reboot, there's something y'all should know. Okay, so a lot of times when you update your kernel, and you followed all the procedures I just showed you on a reboot, everything turns out fine. But sometimes the kernel is so new that a lot of the other packages that are working with the kernel, maybe your NVIDIA drivers, maybe Xorg, Xserver, any of the Wayland, any of that type of display manager and display driver packages, sometimes they don't get updated to be compatible with that kernel. And after you restart, after doing everything I just showed y'all, uh, you won't be able to boot back into your display manager, your desktop environment. It'll just stop right there, and maybe X server will crash or it won't let you in. Um, so before you can usually reboot right about now, and there's no problems. That's usually what I do. And then if there is, I just go back and do a system-wide update. Because this is Gentoo and you have 2,000 packages installed, sometimes it could take a while to update the system. So if you want to play it safe right now, before you do a reboot, and make sure you have all the updated packages, you can go ahead and type in emerge dash dash deep dash dash keep dash going. What keep going is going to do is it's just going to keep emerging the packages even if there's a compiling problem on one of them or a dependency issue a lot of the times. And then go dash dash with dash b deps equals yes. That just gets other dependencies for the packages. So you're going deep into the system with the updates. You're going to keep going with bdeps, and then of course update, and then at world. If you want to save a lot of time, you could do at system. It'll only do the system files, and that'll probably be good enough too. But like I said, if you want to play this completely safe, you can do at world. And of course, this is Gentoo, so y'all know that you might have some questions as soon as you enter this command. And you might have to do some etc updates for you continue, or you might have to mask and unmask some files. But hopefully y'all would know that this is just a little bit different way to do the kernel update, because essentially what you're using is using GenKernel at the same time with the make menu config, and GenKernel also gets your kernel modules at the same time. So it just makes, this is the way I like to do it, this is the way I'd recommend to do it, but that's just me. Okay, and after you did all that, you are done. Just go ahead and type in reboot, and you're good to go. Push enter. And if all went well, you should reboot into your kernel. I'm not going to push that enter button right now because I have Windows running right here and a few other things. So I'm just going to stop the recording here, and yeah, that's it, guys. If y'all need any help, or if you had anything unexpected happen, you can just head over to the forums and post in the kernel area, and I'll try to head over there and help y'all out.